All right, we're going to do that discussion and then this little example practice. So we're going to take out this whole page at once. So the discussion says, if vector C is the sum of A and B, and vector C equals vector A plus vector B, what must be true about the directions of A and B if the magnitudes added together add up? So what that means is, like, if I have one vector that's 2 and one vector that's 3, how do those two vectors have to go together so that my end vector is 5? Well, 2 and 3, 5. They both have to be in the same directions. And in this case, positive direction would be also required. For the second part there, it says, what must be true about the directions and magnitudes if A and B, if the C is 0? That means that maybe I went 2 to the left and then I went 2 to the right, and so then I can end up with 0. So those two vectors have to have opposite directions and equal magnitudes in order for that to happen. What this means for whenever we add vectors is the magnitude of the resultant can be basically any number between the negative of it and, well, magnitude-wise I should say, from 0 to just adding the two magnitudes together. Because as we change that other vector's direction, we can get any distance within that range by doing that. So that's what that discussion is getting at. All right, for the example, that's the one we got started here. It says compute the x and y components. So we're going to go ahead and resolve these vectors into components. So when we resolve them, we want to find those kind of legs of that right triangle. And so this one is pointed in our y direction, so that's going to be our y component. And this one over here is going to be our x component. And so I see that my x component is opposite the angle. So thinking about SOHCAHTOA, that is going to be opposite, so I'm going to be using sine. So this one is going to be 15 times the sine of 30, which comes out to a positive 7.5 meters. My y direction, and how do I know it's positive? Because it's pointing to the right. The y pointing up is also going to be positive. That one is adjacent, so we're going to go 15 cosine of 30. We'll have to type that into a calculator, and we get about 13 meters by doing that. All right, let's do the same thing down here. So when we draw those components, we want to draw them such that that angle is inside of the triangle that I'm drawing. You can draw them over here. The problem is then this angle is now at this point on the triangle. We just have to keep track of that, or we have to find the component of that angle. What is that? The complement? Yes, the complement angle of it there. So this will be our y direction. This will be our x direction. Note our y is still positive, but now our x is a negative number. Our x is opposite, so we're going to be using sine. So that is 10 sine of 53. But I do have to put that negative sign on there. Typing that in, this is a 3, 4, 5 triangle, so this is going to give us a negative 8 degrees. I'm sorry, yep, negative 8. No? Let me check. It says negative 8. Yep, negative 8. Negative 8 meters. Our y is going to give us negative 10 cosine, oops, it's positive, sorry, 10 cosine 53, which gives us a positive 6 meters. There we go. All right, now for your practice, so go ahead, pause the video, try to do vector A and C and resolve those into components, and then come on back. Welcome back. So let me write those values down real quick for you. So this is for vector A. This is for vector B. And for your x, you used cosine. For your y, you used sine for those values. There you go.